to another video. So in the name of Allah, in this video we're going to discuss about how to download and edit a classified image into another GIS and remote sensing software, and also how to use the satellite data of any other satellites rather than Landsat in this environment. So let me to restore my workspace to retrieve the classified image that I did it before. So our classified image is here. Now if I want to download part of this image and load or open or import into the any other softwares, GIS and remote sensing softwares. So let me check it. Which part must be downloaded? I'm going to download this part of this image, just as simple as I show you in the previous video. You can click here, left click, and you can click on download option. So whenever your download panel is ready, you can specify your download area. So I'm going to download this location. So I draw a rectangle for this extent, and the data must be downloaded in zip folder. So the bonds must be specified, the bond of these images classification, your coordinate system or your desired projection, and the image of the resolution, and you can click. Here is an error, so I have to do this again. Network is not working properly. I'm going to draw a smaller rectangle here. So because of the network problem, it is showing an error here, and this rectangle must be downloaded. So once you download your data, you must extract your data and open it in any other applications like NV, AirDOS, or QGIS, ArcMap, anyway that you have. I'm going to open this picture into the NV download folder and CL1. This is. Now you see this is a grayscale picture, shows only a single bond, but when you classify a picture or an image, you need to get a result in RGB model specifying the classes. or an RGB raster that reflects or expose your classes. If I click here and get a quick statistics, you can see here, and classes are specified here. We have three classes, 0, 1, and 2. And each class contains uh, a large number of the pixels here. For example, 41% of the pixels dedicated to the class 1, also 45 dedicated to the class 2, and 13 is dedicated to the class 3. So now I see my classes here. My first class is vegetation, my second class is soil, and my third class is water. And 0 must be vegetation, 1 must be soil, and 3 must be water. So in here, I can use the decision tree. It's just simple. You can search in toolbox of the NV here. You can select new decision tree here. Decision tree is used to select specific classes from a classified or different classified image. Whenever you classify more than one satellite image, so you can import uh, feasible classes into a single file catalog or into a single classified map. So here in this net, you can click here and you can introduce a bond here. For example, its name is Vegetation, and the expression is, for example, I say B1 equal to 0. Any values of 0 in this raster image must be in Bondic must be considered as vegetation as this specified class. And okay, and select here specify your bond. And this class is vegetation. And I specify the color. Okay, this is your first class. Right click on the class, add the children, select on the net, and this must be soil. And here B1 equal to 1. In the class, this must be soil. Again, the value is 1, 2, and the color is yellow. Okay, and at children, here, the class is water, and the value is 3, and the color is okay, blue color. And also in here, water, B1 equal to 2. Okay, let me check the value of this. Okay, okay, okay. And now I can execute this file. I can specify the location or the destination of the file. So in tutorial folder, for example, 3 classes. Okay, and okay. So now I close the decision tree. I'm, I'm not going to save this decision tree and close this. So I can open the file, tutorial 3 class. Now you see your classified image is into a color-sliced or a colorful map that you can continue your processing or creating map or calculating the area of the any classes here. So it was this, and let's go to the next one. In this tutorial, by the way, we used satellite image and mostly Lancet 8. But by this time forward, we're going to see how to work with the other satellite images like MODIS, VIIRS, and check their products and see the product quality and capabilities here. So let's go to the MODIS product. When you click on the MODIS product, you see here 10 rasters or 10 results. For example, nadir, BRDF adjacent reflectance, the MODIS combined 16 and the WI and BAI, EVI, and the products of the MODIS is divided into 2 major categories, that ready products and raw products that you can process and extract the features of the purpose features of your study by processing raw data, or you can use directly. For example, NDVI, NDSI, EVI, EVI2. All these products are ready and can be found via this environment. So let's see, can we find TOA reflectance for MODIS or not? Is there Okay, let's try this one. You can see the details of the data that you're going to add in your workspace here, and the information about the bonds and bond values and name of the bonds and the existing bonds, all this here. And you can decide by viewing this information that this is the data feasible value, or is this the data actually that you are looking for or not. Anyway, I'm going to add this data to my workspace to be loaded. You see the number of the or the date that it means this data is available uh, in daily range for you. You can do any calculation here daily. Any day of the year is available for you. So, for example, you can go to jump to the date, and I'm going to select, for example, May 2020, and here I can, when I apply this, you will see that this is the image of the September 21st 2020. Let me May 2020 and 4th May 2020. And actually the quality of this image is not good, and all the locations here covered by snow and cloud. And I'm going to change July 8 to see how is this. And you see most of the mountainous areas are covered by the snow in these days. So I can use to this image. Now it's better. However, still we have the snow covered area, but it's better. I can apply an image enhancement to get a better resolution or a better visualization. And when you see the bounds here, these are the bounds of this image. So instead 1 kilometer, sensor zenith, sensor azimuth, so range, solar zenith, solar azimuths, and in these bounds. And surface reflectance, we use these bounds to calculate the indices. It's quite similar to Landsat images or Landsat satellites. You have only the name of the bonds here, and when you type your expiration or your mathematical calculation, you must remember the name of the bonds to be typed or entered correctly to get a good result. And I know you remember what we calculated, the NDVI or NDWI. And Landsat images, it was according to wavelengths of the bonds. For example, we used the rash difference of the NIR and read bonds to calculate the NDVI, and SWIR or shortwave infrared, and NIR bond to calculate the water index or to extract water bodies. So whenever you want to calculate an index in any other satellites, you must try to take a look into the Google to know about the wavelengths of the bonds of that satellite or that sensor to be sure that you are calculating correctly. In Moody's, that the bond 1 is considered as a shortwave infrared or infrared bond, and bond 2 is considered as a red bond. So if we try to calculate the NDVI on this image, definitely we will use the rash difference between bond 2 and bond 1. So let's try it. Calculation expression. Select the image, and I'm going to change the name of the image to be easier to be used in calculation, from MG1 to M, and here just open two parentheses and two brackets here, and now into the quotation you can use the bond's name. For example, surface reflectance bond 2, underscore REFL underscore B02. I just copy what I typed here and change the number of the bond. Now I have the name of the bond here. And now I can copy all this and add a division sign and paste it here. So now I can change the minus to the addition mark here, and I can apply. We have an error in this expression. Okay. We must specify the image that this bond belongs to that image. M, and also this bond belongs to M. Now your NDVI is calculated here in MODIS. If you are going to calculate any other indices or any other expressions according to the wavelengths, first of all you need to know about the wavelengths of each bond. In the name of each bond, you must specify first of your computation and first of applying your expressions on an image. You must be aware of the wavelengths of any bonds, and applying any other indices and any other calculations on MODIS or any other satellites are quite similar to each other, but the wavelengths and the number of bonds varies from one satellite to another. So if you want to export part of this calculated image, you can export your image by selecting a suitable area. So, and the data of the this platform are categorized or classified into different classes that you see here. When you click on one of them, and you can see different type of data source here or data types here. So here is the years of the data and or the limitation of the time. This data type provides the data in the interval of from 2001 up to 2009. So you can change your option by clicking here, and this data type is also in the same interval, but these are classes. For example, in 2005 I'm going to specify the water class here, and I apply this. Did you see this is already product, and already water bodies are extracted here, and you see water bodies are added to the map here, and as you see here, the rivers, the lakes, and any other water bodies. And evergreen are the forest that they are diagranes and all the year, and 365 days of the year green. So you can apply to see the distribution and the locations. And also you must check all these to find your classes and what you need to download, what you need to get, and what you need to use in your research or in your project. And for example, croplands. Let's see in this area that you see these are the croplands or the agricultural areas. So for example, urban areas. As you see, when I add the next class, the color of the class is changed. For example, you can see the location or the areas of the cities, which cities are classified as urban areas or as city according to satellite images. And also desert areas and unclassified areas, savanna areas, or shorelands, or grasslands, or any other locations can be specified here. That you can specify your class and your location and get the data and use to your project. according to your necessity, according to your purpose, and according to your study area. It would be specified what type of data that you need. And whenever we are looking for specific data or for specific classes, for example, when we are looking for NDSI, and here you see under the data of the NDSI we have 19 results here. For example, Tira, Sonocover, Daily Global. This is a daily Sonocover data calculated by NASA from projects of the Moody's, and this is ready to be used here. And also, you can find 32D, 2Ds of the NDSI composition as the mean of the since 1982 to 1993, the date of the, or it is data and annual data of the Lancet 5 and also other Lancet products and 32 days on monthly sonocover area of the Lancet 8 and it's the data of the or annual NDSI of the Lancet 8 and I can click here you see that this is a single bond. Let's just wait to be loaded. Or you can show this in a color palette or you can use gamma for your visualization. It depends on you. And from here you can specify the date and the year of the your data. For example, I'm going to see 2050. These are the coverage of the snow in 2000 and 2015. So whenever you want to conduct a research related to change detection in snow covered area uh, in a province or in a state or in a country level study area, so you can use appropriate product of the Lancet or Moody's for your purpose. So any part of this product can be selected and downloaded and easily you can convert this product into the polygons and into the classes and calculate the area overlay the converted vector layers to visually and statically calculate and process to see positive and negative change. These are very essential to monitor the change on the Earth's surface uh, and see or and get outputs related to impacts of the climate change or uh, any other environmental factors. And also, you can look for another data, very important, it's called LSD. So we have 30 results here. You can specify what you need. The data of or interval data of your data depends on your purpose, depends on your research anyway. Here is different type of land surface temperatures already calculated. So you can select and specify what you need. Like here, most of the land surface temperatures are belongs to Landsat images and Moody's and also uh, GCOMC level 3 land surface temperature here. I'm going to open one of these. For example, MOD 1182006 from Tira for Moody's sensor Tira is available here from 2000 up to now. Every 8 days, you can opt in and you can access land surface temperature of any area uh, within every 8 days with a spatial resolution of dedicated to this data type. And you can check out the quality of the data here and the description of the data here. So this is a large scale data. This is not feasible for small locations of study area, as you see here, 1,200 by 1,200 kilometers in each grid. So let's choose one of these data and import it into the workspace to see what happens. Here, Lancet OLI level 2 collection. The dataset contains atmospheric corrected surface reflectance and land surface temperature. Here. And you see here all the information about your data. Mean values, maximum values, and any other information you need. I'm going to whenever you try to import or check the availability of data, you must check out, is this available for you or not? And whenever you see open in your workspace in front of the data name, it means that it's available for you. Whenever you see that there is no open in workspace, it means you don't have access to this data right now, but it will be ready soon. For example, let's see the information about this data here. This is a land surface temperature data available from 1st January 2018 up to 28th June 2020 for 2 years. The resolution of data is 4668. It means each pixels or each grids are about 5 kilometers here. I'm going to add this data to my workspace. And you can see the range of the data, and these are the color palettes that you see here from the lowest to the highest. So whenever you're evaluating a research within a vast area, and the rest of the area contains a large location, so it will be visible for you according to its resolution. So another data that can be accessed here is EVI. Let's check it here. EVI, or Enhanced Vegetation Index, is a vegetation index that is used in sensitive areas in dense vegetations. So as we know, NDVI as a vegetation index will be saturated in some locations that have much more density of the vegetation. So in that time, we need to use AVI or AVI2. It means we have the range of 1 up to -1, or the range of the values in NDVI is between the -1 and +1. So in AVI, we can have variety of choices to expose various type of vegetation covered areas, and also the effects of the atmosphere on some location is visible much more, and the time we can use, or we can have next choice to use EVI or EVI2. For example, VIIRS satellite 16Ds 500 meter. I'm going to add this in my workspace and check out. As you see, color palettes, and I'm going to use the gamma, the storage type of this image, and you can see the vegetation covered area. Whenever you are conducting a research in a province level or in a state level on a district level, it would be a feasible product for you to use from this. And as you see, the vegetation covered areas are shown well. So thanks for being patient uh, from the tutorials uh, from Google Earth Engine Explorer. And I think for now it would be the last video. And the next videos of the Google Earth Engine Explorer will come by coming new capabilities in this environment. I think it would be enough. I wish you to learn something from these videos. Thank you.